In this video, we're going to talk about factoring polynomials. We're going to specifically focus on factoring out a greatest common factor, or oftentimes you'll see that written as a GCF, but I'll always pronounce it as a greatest common factor. I just want to make a note that the word factoring means to write something as a product. So if you're looking at the review of distribution problem here, this is considered factored. This is in factored form, whereas when we're in this form here, we're in distributed form, or oftentimes we'll call that standard form. So let's review distribution just for a minute. I'm going to take 3 times x plus 4. Remember that we'll need to distribute the 3 to the x and the 3 to the 4. So 3 times x is 3x, and 3 times 4 is 12. So I'll have a plus 12. All right, now let's look over at the problem on the other side of the page where it says to factor out a GCF. In our case, we're really just going backwards. If you notice, this is the answer to where it says distribution, and then this is actually going to be the answer when it says to factor out a greatest common factor. So if I'm looking at this and I didn't necessarily have this, I'd really just want to look at what each term has in common. So this has a 3 and an x, and this has a 12. So I'd want to think of maybe factors of 12, and 3 is definitely a factor of 12. So I could rewrite 12 as maybe 3 times 4. And so one way we could think of this is we could say, okay, well this still equals 3x plus, and then instead of writing 12, I'm going to write 3 times 4. Now, if you notice, there's a 3 in all of the terms of this expression. And so what we do is we pull that out and we put it out in front of the parentheses. We write it as a product. And so I'll write this as 3 and then in parentheses x plus 4. Just whatever's left when I pull out the 3. And we could check our answers. That's one of the really nice things about factoring is we could always check by distributing. And so if you look over here, we've already kind of checked this because this was the question here, and now this is the answer. So factoring and distribution are what we call inverse operations or opposite operations of each other. So let's look at a more complicated example where it says to factor this out completely. And we're going to look at what all of these have in common. So we've got a 12x y squared plus 18x cubed y to the 4th. So they have a lot of things in common, and we're just going to kind of play with this piece by piece. Based on my experience with distribution, I know that I'm going to have this equal to a set of numbers, or in our case, letters as well for our variables, and then I'll have a set of parentheses. And I'll probably still have a plus sign in there because of the plus sign right there. And so let's take this piece by piece and see if we can maybe pull out some things. I have a 12 and an 18. Now I want to think about what those two things have in common. Now, we can think of 12 and 18. I know 2 goes into both of those, but let's think if there's anything bigger. I think 6. So 6 goes into 12 2 times, and 6 goes into 18 3 times. So I'm going to be able to pull a 6 out of this. And then from the 12, I'll think 6 times what equals 12, and that's 2. And then I'll look at the 18 and say, well, 6 times 3 is 18. So I'll have the 2 there and the 3 there. Now, let's look at the x's. Same idea here. This term has an x and this has an x cubed. And I want to factor out the greatest common factor. In our case, the greatest common factor is the x because that's the thing that they both have in common. So I'll still pull out an x. And this first set here won't have an x with it because it's been pulled out. And then this next one, what do I need to make up an x cubed? That'll end up being an x squared. So I'll make sure I have an x squared there. Okay, and I can always just check this too. I can go, okay, well 6x times 2, that's 12x, and 6x times 3x squared, that is 18x cubed. So I'm on the right track. I haven't really made any mistakes. The last thing I'm going to do is I'm going to look at this y squared and this y to the fourth. If you notice, again, I'm looking for the greatest common factor, and the greatest common factor is the y squared. So I'm going to pull that out. And now, because this was a y squared, I don't need a y squared there. But here, because that's a y to the fourth, what times y squared equals y to the fourth? Well, that's going to be another y squared. So I'm going to have a y squared here. And we can always check to see if this works. We can always multiply this out. So one thing I might want to do is I might want to say, okay, well, let's start with this 6x y squared times 2 plus 3x squared times y squared. And I'm going to multiply it out just like we've done in the past and see if it equals that. It's just a good way to check your work to make sure you're doing it right. So I'm going to do all of this times the 2. Now 6 times 2, that is 12. And then since there's no variables right there, I'm just going to have the x y squared right there. So I'll have an x and then a y squared. And then I'm going to do that to the next term. So the 6 times 3 will give me an 18. And then the x times x squared is an x cubed. And then the y squared times y squared is y to the fourth. And if I look at this, this is the exact same thing right here that I started with. So I know that my answer is correct here. And before I circle my answer, I'm just going to write it without that gap there. That just kind of annoys me a little bit. So just going to do a line there to separate that. And I'll say, okay, well, my answer is 6xy squared times 2 plus 3x squared y squared. And that's my answer. I really enjoy factoring because I can always check my work through distribution. Now it looks like I left a parentheses off there. Let's throw that back on.